Thank you everyone for coming to attend my talk titled Harnessing the Sunset to Cure Seasonal Depression. I think that Seattle is a great place to live. I've enjoyed all of the mountains, forests, and lakes offering year-round adventures. And there are a few places that find my favorite outfit, a down coat and shorts, acceptable. But there is one caveat to living here. Many Seattleites feel tired, unmotivated, and depressed in the winter. This is called seasonal affective disorder, or SAD. My goal is to find effective treatments to prevent SAD. SAD occurs because our bodies are clocks, and they can get misaligned from the environment, from the clocks on our phones that tell us what time we need to be somewhere. Are you tired at 7 when you have to get up? It's because your body still thinks that it's 4. Just like you can adjust the time on your watch, the sun can dial the crown of your inner clock to make sure it's set to the right time. It does this because light sensors in the eye talk to the clock to tell it what time it is. But in the winter in Seattle, the days are dark and cloudy. So many Seattleites don't get enough sun to reset their inner clock. This lack of sun causes SAD. To prevent SAD, we need to find indoor lighting solutions that effectively reset your clock. Let's look at sunlight, since it's the most effective treatment. When you think of sunlight, you probably think of the bright white light of midday. However, at sunrise and sunset, the light changes colors and intensity. Most sun lamps mimic the bright white light of midday, but these lamps are so bright that they're difficult to look at. Unfortunately, the light sensors in the eye that detect white light need bright light to reset the inner clock. If the brightness is turned down to the brightness of normal room light, the signal isn't strong enough to dial the crown of your inner clock. Therefore, we need to look at sunrise and sunset to find a comfortable solution to making these lamps. Although sunrise and sunset only occur for a short while each day, they are important for telling time because they mark the transition between the light and dark parts of the day. Furthermore, the light sensors in the eye that detect these colors are much better sensors than those that detect white light, so the light doesn't need to be as bright. Therefore, this could be a great solution to making the sun lamps more comfortable. As you look across the sunset, your eye moves so that it sees the blue color, and then the orange color, and then the blue again. So I've plotted what your eye sees here. When the light sensors in the eye see the blue color, they respond very well. I've plotted the tick marks represent this response now. When the light sensors see the orange light, they stop responding. This on-off response is very important because light sensors will get tired if they have to respond constantly. We made a lamp that mimics this response, but appears white and is the brightness of regular room light. It works by flickering between the colors so quickly that it appears white, but the light sensors mimic their response to sunset. We tested whether this lamp could reset the inner clock in humans. We first measured the timing of the inner clock before the light treatment. We did this by detecting melatonin in spit samples. Melatonin is like the hands of your inner clock, telling us what time it is set to. Melatonin, if the subjects were synchronized to Earth time, we would expect melatonin to show up in the spit at sunset, represented by the dashed dot here. Here is the time that the average time that the melatonin shows up in spit samples from subjects in Seattle during the winter. All the subjects from Seattle were delayed, meaning the melatonin didn't show up until well after sunset. Imagine that you're a professor and you have a class that starts at 6, so you show up at the dashed dot. The black dot represents the time that your students show up, thinking that they were perfectly on time. After this baseline measurement, we gave the light treatment. When we remeasured the timing of the inner clock, we found that it moved forward an hour and 20 minutes, represented by the blue-orange dot. Therefore, in order to make a light that was comfortable and effective, we just needed to harness the power of the sunset. Thank you.